Hey, and welcome to the new topic that is time series. In this video, we will talk about what is time series, why they are important, and how to use it. I'm pretty sure, guys, you have seen that we try to predict some financial details sometimes. Sometimes we try to predict the stock price, and which is a very excessively used case of time series actually. So we want to predict the future stock price, and we know the current stock price, and we know the past stock price, and we try to predict the future. There, in this case, we only have one thing common, that one axis, and the main axis that we have is time only. So this axis is only time. Now you may have any axis apart from this. The main axis always remains the time axis only, and the next axis what you will usually have is the values. So stock price values is at this axis, and you have your time and the other axis. So what really happens? It is predicting what will be the future stock price. So the past is coming and we want to predict the future. So we have something like this. Say this is our line of stock, okay? And something like this is going on. So up to this point, we know that we are predicting we are knowing the past. So we know the past up to this point. So we know the past up to this yellow line, okay? This is my time domain. This area will be my today, okay? And after this line, yellow line, that will be my future. This area, this yellow area will be my future. And that is what I want to predict. That is what I'm willing to predict. So how the things really goes on. So after this, we predict today. We actually don't predict it. We have today. Okay. We use this today area as our testing area. And then we finally have the future prediction. So what's going on in this particular area? This is our past. This is present. And this area is future. And that is how time series really work. What we do, this became our training area. Guys, I'm assuming that you are already aware of at least machine learning logical things that we have a training test data set. So this area is test, okay, and this will be my prediction, okay. Now this is how things really work here. So we have past, we have present, we have a future, okay. Let me put a rectangle over this. You have the clear vision of this. This is my time. This is my past, train area, test, stock price, prediction, future, and presence. Okay. So now how the thing really works. What we do, guys, we simply use this train area and we create a model. Now, what are the models? What we do with the models, stuff like that, we will be discussed later. But for now, try to understand that we have this past details of the stock price and we build a model around it. Okay. We have something called seasonality and trend in the data set that we will discuss later in depth. But right now, try to understand if the trend is there, then things will either go up or down. The seasonality means the repetition of a particular area again and again on an annual basis or monthly basis or something like that. Now, stock price does not really entertain any of those. Uh, in a generic fashion, you can say stock price is again very hard to predict and sometimes very predictable. Again, it depends on the data set and the stock that we are working on. So when we start working, we have our training area, the past area, then we have our test area, the present area, and then we have our prediction area, which is the future area. So we predict the future, this future, and try to predict it to a level where it is not too far. So again, time series has a limitation. We should not be predicting a very far away kind of future. So prediction should be in a limit. So you would say that I would predict only up to this area, not too far away. Now, what is this area is a different scenario again, guys. But yes, up to this area, I don't want to predict too far. Why? There's a good chance that if you are predicting to a very far away, area, say I am predicting the stock price after 5 years, that might not be very accurate because obviously a lot of things can happen in that particular area in these 5 years. Like in the past, we have seen the COVID has impacted the stock price a lot. Nobody could have predicted that any kind of scenario, this kind of scenario could have happened. So stock price fluctuated to a great extent. Same thing can be repeated with anything. You can have a crash. You may have, all of a sudden boost of economy. We might find a gold, a lot of gold somewhere in the sea and somewhere around like, and all of a sudden the stock price goes very high or very low. And this kind of impact can be very high. Even the currency may fall, and that also can impact the stock price. A lot of thing happens in the stock price, to be very frank. So you cannot predict the next 5 year, but yes, predicting for next month or say next 6 months, that is something that you can do. Even for a year is okay. So if you want to invest in a long run, you might want to predict the next few 12 months or 6 months. So if you are investing a huge amount, you are sure that you are investing in a great stock or good stock. So you compare 5 or 6 stock that are your top picks, and then you just predict their future. And as per the prediction, you go on. Okay, I will invest in this and that, and then you just have the you know solution at the end. That is how things really goes on in the market, and that is how time series really work. So this is the main gist of time series, how the time series really work and how they really are responsible for finding you the future stuff. The main thing that you need to capture at this moment is time series is why so far you can see the main axis is time only. So time will be your main axis for always. Okay. So time is your main axis and you have to predict around your time axis. Okay. This is your main axis, time. So time becomes your main axis and any other axis. Now, I'm not saying that you cannot predict with other features too. Means you cannot have other prices or other kind of features too. You may have more than one features too in the time series, but we will be considering one feature only, and we will be working around that too. Because having more feature make it extremely different, and I don't want you to be confused in the starting stage. So we will try to focus on one stock price, one feature, and one time axis. And we will try to discuss how we can predict the future when we only have time axis and one stock price or one rate or something like that, and how to work with that kind of data set. Okay. So let's jump on our time series sheet, and now we have some important points that time series is a sequence of observation over a certain period of time. A univariate time series. Now, guys, univariate is when you have only one features involved of a value taken by a single variable at predicted time instance over a period. Okay, a multivariate time series consists of value taken by multiple variables at some period of time instance of over a period. So, multivariate time series also there. Univariate time series also there. Our project will be focused more on univariate, so we get the clarity or the basic concept. If you have the core, then multivariate is not a big deal. You can easily work on that. You just need to plot multiple lines. That's it. So time series has four major components that you need to know: the level of it, the trend, the seasonality, and the noise. Okay. Now it means the value around which the time series varies. Okay, that's your level. Trend is the increasing or decreasing behavior of the variables. So as I told you before, that time the values may go up or down. So trend is nothing. It is like this or this. Okay. This is going down trend. this is going uptrend. Okay, that is how the trend works. Seasonality, it's a cycle behavior of the time series. Now, seasonality means, guys, if you have, suppose I'm explaining the seasonality. So, suppose you have a data set and then you have a fluctuation. Okay, then you have some data set, then you have fluctuation. So, every few months you have this fluctuation. Okay, this kind of data set is called seasonality. Do you see this peak? It comes after a particular interval of time. So, that means it is a seasonal data. Suppose this is 1 year, this is 1 year, this is second year, maybe it is the sales of gift. Okay, so every time at December, okay, when the Christmas is there, we see a peak in the sale of gift items. So that's cyclic order, that's seasonality for you. And there is something called noise. Now, guys, noise is like this, means you may have any kind of data. Now this data has no trend, no seasonality, nothing. It is just a straightforward noise. These kind of data areas are not really useful. We cannot really use it anywhere in any way. But yes, we have to, go with it. So these are the factors that we need to know. So time series has four main component, and time series basically the observation of the data at a certain amount of period of time. And we have trend, seasonality, and noise and label. Label is basically the how the values of the time series varies as per the series values. Trend is whether it is going up or down kind of values, and seasonality is a cyclic behavior that we observe in the data set. Noise is something that is unwanted kind of area where the noise is there, a lot of fluctuations are there, which does not give us any sort of information. They are just noise. Okay, if they were not there, that would have been a far better things rather than having them. Now this is how the work is done in time series. Now let me now we have a lot of kind of models in the time series that we will discuss in the coming time. Again, I don't want to discuss the models in the first video on itself, but yes, we need to understand few so let's go to the important points that we should know about time series. So in the time series, the amount of data that we are having, that we use to predict the data set, or you can say predict the future, that should be good. It should not be like, yeah, you have just 1 month of data and you are trying to predict a 1 year of forecasting. That is not practical. But if you have 10 years of data and you want to predict 1 year next coming year, that is okay. Okay, so the ratio is usually 9:1. 9 for the training part, 1 is for the forecasting part. And short duration, again the forecasting is good. Again, the spelling is wrong. So forecasting only for short duration is okay. So you should not be forecasting for a very long duration. That will never. All right. So again, the forecasting will never go good if you are trying to predict a very long duration. Even if you have data set, say 10 years of data set, and you want to predict next 10 years, that will never go in a good way. Okay. Again, guys, a prediction should be of short duration, very next moment. That is far better. Predicting for a long future is not good. The reasons are things are very unpredictable. You don't know what will happen. And suppose I give you an example. If you want to say invest 1 crore, 1 CR, 1 million in a stock, and you want to predict what will be the next 10 years of this stock, that is not really practical. No matter how well accurate model you create, you cannot predict the future. There is no saying what will happen in the future. Okay, so better to just forecast coming sometimes 1 month, 2 month, 1 year. That is okay. Now dependency of the previous data, that is guys, if we are predicting something, that should have some sort of dependency. So it is like that. You can say that we if we are predicting say one point, so we are predicting this point, and we have other points too. We have other points in the past. Okay, so this point should depend on this point should depend on this point, and that should be so some sort of dependency of data on each other. should be there. That is really required. Okay. And there should be no gap. It should not be like that gap series is like this and this area is completely lost and then it continue from here. This area is missing, that means you cannot use the dataset as a time series. Okay. That is a restriction that we have. Forecasting too long in the future usually not good. As I told you before, guys, same point again, don't try to predict a very long future. If you have 1 year of data, 1 week of prediction is good, 1 day of prediction is good, even 1 month is okay, but not more than that. That is more, above that is not assisted. To forecast, use a stable part of the series. Now guys, we have this kind of series, then we have this kind of areas, then we have this kind of series. Okay. So these are pretty stable, you can say. These are not really stable. You ignore the unstable part. Now guys, I'm not saying this is a purely stable area. Yes, we have to do a lot of study on this stability and non-stability. It is more of a called stationary data set, but yes, we will talk about that later. And we have to check that, we have to mind that, and we have to work accordingly. So let me remove all this. Let me scroll down for you. And guys, if in a test train, use most recently part of the test, and data is continue, not random. It means the data should be continuous data. As I told you, there should be no gap, there should be no random points taken. The data should be like 1 day, 2 days, 3 days, 4 days, like that in a sequence. Continuous data should be there. And the test part will be the most recent part. So if I am predicting something, I want to make the test area for today or yesterday, or not long, or not more behind than that. Okay. If you use test data like that, that will be giving you a better result and clarity at how well the model is performing. So you have 10 years of data. So this year will be taken as test year, and the remaining 9 years will be taken as training part. And the coming next year will be the future that we are going to predict. How to prepare data? We have to done a few things to convert our data into the time series object. Now let me clear this. It is not really that much visible at the moment. Let me make it like this. This will do. All right. So convert the month column from string to date and time. Okay. So whatever month column you have, you convert that to date and time. Now guys, this is how we prepare our data set for the time series. So converting the month data into the column into the date and time part. Set the transform date time column as the index. So you make the time column as the index. Extract year, month, weekdays from the index and store it in a new column. So you create new columns features from data set. You extract the values as per your week, days, month, and stuff like that. You create new column, and then you can do further R&D on that too. Now again, extracting that part is not really that much necessary at the moment, but yes, we have to convert the time column into the index and converting into parse it into data time column. That parsing part and the stuff will be covered specifically when we do the coding in pandas and when we import the data set. I will show you how to parse, how to control that parsing part too. Okay, that is the pure core knowledge that we need to know before we can do anything for the time series part. Now guys, again, uh, we have discussed the level, seasonality, and noise. Okay, trend 2, we have discussed that how to prepare our data set when we have a data set, and how to convert the data time column and where to put it and how to use it. We discussed the important point of the time series that we need to mind when we are working on it. We discuss what is time series. These are the points that we have discussed in this video. In the next video, we will try to do a little bit, work with the data set. I will also talk about the kind of model that we need to know in the time series, and what to do, guys. So these are the few data set that we have, models that we have, we can use, and we will use few of these models. Again, LSTM is the deep learning model, so we cannot really use every model at the moment, but we will do that LSTM part when we reach to the deep learning part. So Dickey Fuller test and all the seasonality, autocorrelation, and Arima model, seasonal Arimax model, V Arimax, Arima model. We will talk about all these models, how they really works, what are they, and a lot of theory is about to come. We have to create a proper video for model only, so we can discuss all kind of models that we have, and which model to pick at what position, what are the specialty of the models, and what is Arima, Arimax, and AR, MA, and I part of it. We will discuss all that. So in the coming video, you will see all these things and how they really work. And yes, we will discuss a lot of coding and errors that we have to resolve, how to convert and parse the dataset and stuff like that. So let's get prepared, buckle up, and strongly recommend that you create a separate sheet for this time series projects, because you don't want to mix it with the normal dataset. One more thing that we need to understand when you're working on it, it is an extension over regression. We know the regression, but in regression we have multiple features. In time series we have our main axis as time, and hardly one feature is there that we want to predict. So target value and the time column is there, and we want to predict the future. So we cannot use regression in this kind of scenario. Regression fails, and that is why the time series come into the picture, and that is why you can say that it's an extension over regression part. So if you have any you can say if the regression is not clear to you, have any doubt in regression, it will be a good time to revise the regression and how regression really works. The understanding of regression line can help you a lot to understand the time series line. Okay, so that is all. Let's see you in the next video, guys. This is all for the video. Thank you. Now, after understanding the time series techniques and the way we have to know about the trends and the seasonality and stuff like that, let's discuss the modeling part. We have different kind of models in time series. So Arima AR model, MA model, V Arima model, and fractional Arima model is also there. We also have an LSTM model, which is again more to the deep learning part and less towards the machine learning part. But let's discuss all of them. So naive Bayes method, these are the simple estimator techniques such as predicted value in given the value. So basically it's given the value to mean of the presiding values of the time dependency variable. Now reading the whole para doesn't going to make much sense, but again, we can say that these are not very decent model or very good model, but they do a raw job or rough job of getting the job done. Okay, so what they really do, basically describe the time dependency variable and previous actual values, and they just simply see the comparison and give you the result. That's it. And that is why the name term is used for them, because they don't really consider any relation, anything like that. They just get the job done directly, and it is the first shift. You can see the first model that you create, and you compare all other model output with this naive model. Okay, so guys, let's think about it like this. When you start with time series, we don't really have a way of checking it directly. What we do, we create a basic model here. Okay, this is my basic model, and you can say a naive model, the first estimator, whatever you want to call it. We do simple thing. We have this row, we have shifted second row, we subtract the first row value to second row, and we get the results here. Okay, as per these results, we predict it with the model, and we get some sort of output. We find the mean square error. Actually, root mean square error is what we found. Okay, we find the RMSE. Okay, after finding the RMSE of naive model, or you can see the estimate model, the basic model, we move forward. Okay, and create our Arima model. Now Arima depends on several things that we will discuss later, but we use other models, say Arima model, and then we again calculate RMSE for Arima model. Okay, the aim here are few things. First of all, how the model is performing, we check the mean. Okay, mean value that we are getting should not be far away from the RMSE value. Basically, the root mean square error should not be you can say very high from mean that we are having. That is first worth checking. Guys, again, not a very correct way, but a raw idea is taken from here. Second, the Arima model that you are creating, or as Arima, whatever model you're creating, the root mean square error of this value should go less than this error. So this value should be lesser than this value. That is what we need to know. If it is less than RMSE of naive model, then this model is accepted. Otherwise, this model is completely rejected. And that is the main core idea of creating the time series modeling. So let me clean this. So next is Arima model. Now, what Arima model really does, it simply do a simple thing. It tells you that you have a combination of Arima and moving average and integrate at the center. Before that, we need to understand auto regression, that is AR model, and then moving average model too. So I give you a basic idea before reading the value. Actually, I give you a basic idea. One uses the error to predict the future, and one uses the past value to predict the future. So Arimax, that is. So auto regression first. So auto regression basically, regression predict the value of the future time period as a fraction function of a value at previous time period. Basically, it checks the old time period to give the results for this time period, and the prediction of the auto regression may fit the data better than the naive model. But if it not able to account for seasonality, again guys, seasonality is one thing that will play a great role very soon, and we will explain you all the things about that. But guys, again, it says the same thing, that it is using the past value to predict the future values. And again, regression may fit to the data better than the naive model. That is the basic model that you have created. And if it is not able to account the seasonality, then yes, the things may change. Seasonality is nothing, guys. If we have a time series value, so basically, if we talk about time series values, okay, I told you already that that pattern that is repeating is basically the seasonality. So the seasonality is present, the way of doing things changes a lot, okay, and the seasonality is not there, and the only trend is there, okay, only trend is there, the upgoing trend is there, okay. So then the things are different for us. Now, so Arima model and as autoaggressive integration moving average. So basically, it is a combination of these three. Okay. Now, guys, moving average is also need to be discussed. The moving average model is basically it checks takes the error in the countability, and then it try to predicts the value of the future by using the error part. Okay. So model of the value variable as a linear function of the previous value and residue error at the previous time step of the stationary time series. However, the real world data may be non-stationary and have stationarity. Thus, seasonal Arima model and fractional Arima were developed. Arima work on univariate time series to handle multivariate. We use V Arima was introduced. So when we have multivariate time series, we use V Arima, and when we have univariate time series, we use Arima model. And when we have seasonality with the data, we use S Arima, seasonal Arima model. So that is how the models are differentiated. Exponential smoothing, it models the value of the variable as an exponential weight linear function of previous value. The statistical model can handle trend and seasonal as well. So this is also a way of doing it. Now, as LSTM, long short-term memory use model, is a recurrent neural network. Guys, again, it's in deep learning part, which is used to offer time series to account for long-term dependency. It can train the large amount of data to capture the trend in multivariate time series. Guys, again, remember the word multivariate here. That means LSTM is also used for multivariate time series. So if you have single data, you can go with that Remax and Arima, basically Arima, and that will solve your problem. If you have seasonality, use as Arimax. If you have you can say multivariable, so we Arimax is used. And if we have single, we use Arima. And if you have you can say um, multi variables, multi features, you can say we can also use LSTM, which is a neural network part, which is again when the data set is very long and the processing is too complex, we can use LSTM in that situation. So that should do it. Let me clean all things.
So the frame of where we are going to cover this time series is that we will discuss these methods, excluding the LSTM. Obviously, it will be in the deep learning part. So definitely, you need to understand the neural network far before that you can understand LSTM. So it will be a later topic. So leave this part for now. We will discuss autoregression, moving average, which is very rarely used. Even autoregression, moving average is also very rarely used. So these three top models are going to be discussed in simple fashion. You're not going to do any deep project on this because this is not really preferred these days. Then we will discuss in depth, you can say, Arima model, Arima model, Arimax model. Now, why the Arimax and Arimax is different, what we do in that, and vector autoregression model, vector autoregression moving average, and vector autoregression max. So var max basically, yeah, Armax, you can var max, whatever you want to call it. And then we will discuss a little bit of SES model, that is simple exponential smoothing model, and halt winter exponential smoothing, HWES model. uh, Again, this is a model that maybe you can see use in a different case in simple scenarios, but we will discuss all of those. So few models like LSTM is not going to be discussed in this time series but particular part. We will discuss that after deep learning. Apart from that, other model that we have, we will discuss middle models in deep, the top three models just for the introduction part, so you know the difference between these models. That is important. And we cover all this step to step. So first the auto regression, then moving average and stuff like that. So this was a theory that we discussed. This is the main seasonality and stationary part that we have discussed already. Autocorrelation we will discuss in a very in-depth part, and decay fuller test will be done in the project directly. So let's start back to back. But guys, we need to know few more things before the project part. We need to understand the time series data functionality in pandas. So how time series data is handled by the help of pandas. So we should know few functionalities here. So timestamp, time delta are the things that we need to know. Or you, if you are aware of this basic date and time library of Python, that will also do. So if you know date time library of Python, that is also more than enough to understand the pandas functionality. They are almost similar, and they give you almost same sort of knowledge. So time delta is also here, so you can use this too. And we use this functionality very frequently, and we will be using it for the data set. So we will have a proper lecture for this too, so we can discuss the basic functionality. Not every functionality, guys, it is not practical. It is a huge documentation. If you go till the end, there are n number of functionalities, but only 20% of the functionalities are really used frequently. Other functionalities not really used. You may say I have not used it for extremely long time, so not worth it to read everything in the documentation. Now it is never worth it actually, guys. Out of the whole documentation, only 25% or 20% stuff really get used, and other parts are only for unique case or special cases. Okay, so we'll discuss as much functionality as possible. You can see the index at the left side. We will discuss the pandas time series functionalities, and once you're done with these two videos, we will move towards the main time series model functionality. So we will have few back-to-back videos for time series, and we'll cover time series properly in average prospect that we will need to cover. So that will be all for the theory video, the introduction part. I think you have enough idea that what are the topics that are coming, what are the things that are coming. So you have a framework to think of. Even if you want to do some R&D over these topics, you may go ahead and R&D on those topics, and it will give you more clarity when you start working on it. So let's start with the next video. Let's move to the next video, where we will start with the Python date and time, and then we move towards pandas time series and date and functionalities. Then the third video will be about the functionality of the time series and stuff like that. So that is all for the video, guys. Thanks for watching.